Hello everyone. So we started this company in 2011, right after the revolution. And at that time in Egypt, it was the worst time to think of a business. It was the worst time to think about investing because things were really unstable. And I realized something, I learned something over the years, that when you realize that everyone is looking towards the left-hand side, that there has to be a potential on the right-hand side. So this was something that for me meant that this is the time to invest in something new. And that's when we started KarmSolar. The key to integrating sustainable renewable energy production into our daily life is to stop using the word green and to stop using the word sustainable. What we really should be focusing on is making sure that whatever we're producing and the solutions we're designing make sense, they solve a problem, they're economically viable, and they're just the best thing that is available out there. Why is that? Because if you try to sell something to someone based on their good nature, you will sell it to them once or twice, but that's it. But when you're solving a problem for someone, they will keep coming back. And it's not because we're bad, but because that's how we function. We have to design our products and services to be compatible with the incentives, the things that move the people around us. And that was what we were trying to do. We never sell our solutions in solar energy saying that they're green or sustainable. We just sell them saying that they're the most economic option that the people have when we go to them. So, when we wanted to work on solar, we did not want to be a solar installer. We wanted to look at the intersection between solar energy and many other things. And we wanted to design solutions that really embed solar energy or solar technologies into other components and other things that people work on. So for example, there is a very interesting intersection between solar energy and architecture. I'm going to explain that in a bit. And at the same time, we wanted to use solar energy in order to empower the values or to strengthen the values that we believe in. Right after the revolution in Egypt, it was very important to be independent. And that meant not to depend on big businesses and not to depend on the government. The grid, whether it's the power grid, the water grid, the sewage grid, is a form of control at the end of the day. It's a form of control of the government over its citizens. It's a form of control of big corporations over the areas that they serve. Now imagine the amount of empowerment that you would be able to give to people, to businesses, to farms, if they can produce 100% of the energy that they consume, if they can produce the water that they require, and if they can treat the water that they need. This is something that has a lot of economic value. I'm an economist by training, I'm not an engineer. And this is something that renewable energy really needed. We have a lot of really smart engineers in that field, but we don't have many economists, and that's the problem. So this is the thing that I was working on, coming up with the economic formulas that would allow solar energy to be the main source of energy globally. Now, this is our campus in the Black Desert in Egypt. It is running 100% in solar energy. It was constructed by stones that were found just a kilometer next to the site where it was built. It's in the middle of nowhere, and right now it's an important center of attraction in that area. Why? Because it makes sense. It has 85% less bricks and cement than what you would require to build a similar building. It's economically viable in terms of energy generation, and it's completely off the grid, and it became a center to provide solar stations in an area around it. Right now we've installed more than 40 stations around it to serve the farms that are working over there. So how are we going to take that concept of off-grid to a global level? I will take the case study of Egypt because that's the one that we started with to show you how this can be applicable everywhere else. But before I start talking about Egypt, I just need to explain something called disconnected development. The idea of what we are trying to do right now, we decided to call it disconnected development. And what it means is developing an entire economic model that has the same or better living standards for people that is completely independent from the grid. Because right now, the way we think, the way economists are thinking about urban expansion is that they look at where the grid is and they look at the cost of connecting a new community to that existing grid. Now imagine if you don't have to do that. Imagine if you can establish a community that makes sense anywhere you want, depending on the opportunities and resources that you can find in that area. That you don't have to be connected to a specific grid. Now, that might seem like a problem that doesn't exist because we don't get to think about it. But in the extreme case of Egypt, we had to think about it. So the type of problems we had in Egypt forced us to think early on about something that people are going to be thinking about a few years from now. If you look at Egypt, you will find that it's really mainly desert. And then you have the Nile River and the Nile Delta in the middle. And that's basically where everything is happening. So, if this is the Nile and this is the Red Sea and up there is the Mediterranean, you will see that Egyptians live on 8% of the land that they have. So 99% of the population lives in those areas that are marked in yellow. And those areas are exactly where the grid is. So in effect, the power grid, the water grid, the sewage grid, they cover 8% of the area of Egypt and 99% of the population. Believe it or not, everything you know about Egypt, 7,000 years of civilization, only happened at 8% of the land that we have. For me, that means only one thing. Imagine what we can do with 92% of the land that we have. And that's the main question that we ask. How can we have cheap and easy access to 92% of land that has a lot of resources that haven't been used yet, and how to do that in a good way? So we started looking at what are the resources that we have, and we realized that the most homogeneous resource that we have that exists everywhere is the solar belt. Nearly all of Egypt lies on the solar belt, and that's an area globally where you can produce where you have the highest productivity of solar stations in terms of the amount of electricity that you can produce. So then, we thought of something called economic intersections. So it is not just about solar energy. The value in solar energy does not only depend on the technology that you develop for producing electricity. The value of solar energy depends on how can you embed it into other sectors. How can you find the intersection between solar energy or solar technology and other applications that can be used for it? So when you look at solar independently, it's a very different story when you look at the intersection between solar energy and architecture, or solar energy and water production, or solar energy and agriculture, and so on. How can we embed the economics of both of them together so that they're dependent on each other in a way that would empower agriculture, for example, or water production and make it more economic, and also change the way we look at our perceived reality about what our house means and what the farm means and what the bottled water means and so on. To be more specific, if this is the solar belt, and you have resource number one, let's say the seashore, then at the intersection of the solar belt with that resource, there lies an economic opportunity. So for example, you have the seashore with the Mediterranean or with the ocean or with the Red Sea, and if you find the proper economic formula for how you can use solar energy for seawater desalination, then you have a fabulous economic opportunity. The same thing for architecture. If you're able to integrate solar energy into buildings in a way that can change the way we perceive our houses, the way we perceive our houses today as consumers of energy or consumers of services. Imagine if you change the building unit of society, the house, to be a productive unit, just like a factory. And even take it a step further. Imagine if that productive entity, whatever it is producing, is consumed in the exact same place like it is produced. And that would make it extremely efficient. This is exactly what we're working on. Those intersections are what is enabling solar energy to be more economic and to be viewed in a very different way. So the first thing that we looked at, we realized that Egypt is sitting over a massive water aquifer where you can produce a lot of underground water. And that water is currently being produced using diesel. So we thought if we come up with a technology for solar water pumping that is more efficient than all the other options available, it would make it more economic to produce water. And that's what we have. Off-grid water production that does not depend on batteries and that is working basically to produce water whenever there is sun, store it in lagoons, and then use it whenever it is needed. Then we looked at another thing. We realized that in construction, you depend a lot on cement and concrete, and you depend a lot on using bricks. And those bricks require a lot of energy to be produced. What if we use stone? Why aren't we using stones, for example? So we found that if we design buildings that are capable of being designed using stone and that consume much less energy in heating and cooling and so on, you can actually produce buildings that run 100% on solar energy. So we created an entire company that does only that. Architecture of sustainable buildings that produce 100% or most of the energy that they require. That village in the Black Desert, also in Egypt, houses around 500 farmers, and it produces 100% of the energy that it requires. And it's perfectly economic. And it was built using 85% less bricks and cement, again. So imagine, and it is completely off-grid, by the way. Now, the thing is, you have to start somewhere. We haven't really achieved everything that we're trying to achieve yet. There is a lot of work to be done on desalination. There's a lot of work to be done in really integrating all of that into the one house. The one house that does not need to be connected anywhere. Right now, if I want to start a new community anywhere, I have to look at the cost of distribution. What does that mean? Economics today, if you want to build a city. You have to look at how much it would cost to have a central power station and how much it would cost to have a network of distribution of cables to distribute that power to all the houses. In economics, this is the most efficient way of doing things. What we are proposing is that there is another efficient way of doing it, is to actually, instead of having that central station and that distribution network, if you manage in reducing the cost of generation on a local level, you can have houses that produce 100% of the energy that they require. And thus you will not need any other distribution. And thus, the cost of connecting to the grid would vanish from the cost of building new communities. And that's the idea. Thank you.
Cool. We have time for one question. I think there was a straight away, hands up. Okay. It's alright, it's very soft. This is a Catchbox, everyone. Really cool company and startup. Go for it. Question.
Yeah, thanks, great talk. I didn't quite get the idea behind 92% usage of the land. I think the fact that you use only 9% or something of the land is quite a good thing, because the current trend in urban development is to use less land, build more complex cities. Because if you build a new city in the desert, they might be like super energy efficient, right? But you contribute to the overall like negative environmental impact because people commute more, right? You produce more energy and waste when you transport goods, etc. So have you considered those kind of things? Like, why do you want to people live on the rest of the land? Why do you want to like extend?
This is exactly this is exactly the premise that we're challenging, and that is the mainstream of thinking about efficiency. That efficiency lies in centralization. However, what happens is when the cost of power generation, for example, goes below the cost of distribution, it doesn't make sense anymore, and that's already happening. So right now, what's happening is that the development in technology of power generation and power storage is going very quickly, and the costs are going down, that it doesn't make sense to distribute power anymore. However, the problem is that our houses, our factories, our farms are not yet designed in a way, are not yet friendly with those off-grid, localized modes of power generation and consumption. Now, when you say that the net effect of living in the desert because of commuting increases the, for example, the carbon footprint of transportation and so on, I can easily challenge that, because when you have congestion, the waste that happens because of congestion is much, much higher than the waste that happens when you actually live somewhere else because of the traffic, for example, and so on. So it is not really, I mean, it does happen, but you can't really generalize that. You have to look at case by case.
Okay, cool. Big round of applause.